And upcoming next, we have the MDRS Crew 245. And I would like to introduce the host of Red Planet Live podcast. His name is Ron Craig, and I'm going to hand it over to Ron to introduce the crew. Ron, can you hear me?
I can, Carrie. Thank you very much for that introduction.
Absolutely.
Okay, so I'm going to introduce. It's actually my pleasure. I'm actually really excited to talk to these individuals again. I actually had them on my show not that long ago, and they were fantastic. So I know everybody is going to really enjoy what they're going to talk about today. So I'm going to introduce the crew. So Crew 245, so their mission date was April 11th to the 24th. And what I'm going to do is I'm going to share out some little slides I hope to keep myself in check. Awesome. Okay, so here we go. So here is the crew. So Crew 245. So first up is the crew commander, Dylan Dickstein. So Dylan Dickstein is an aerospace engineering PhD candidate at UCLA, studying thermomechanics in hypersonic vehicles. Dickstein is a pilot, scuba diver, inventor, published author, professional photographer, and marathon runner with work experience at SpaceX, Virgin Galactic, United Launch Alliance, and the Aerospace Corporation. And next up is Shravan Hariharan. So Shravan Hariharan is an aerospace engineering graduate student at the Massachusetts Institute of Technology, researching Martian Institute Research Utilization, ISRU. Hariharan is an avid musician, tinkerer, and citizen of the outdoors who has previously worked at NASA, Northrop Grumman, Spin Launch, Blue Origin, and the Jet Propulsion Laboratory. And up next is Olivia Ettin. Olivia Ettin has earned a bachelor's degree from UCLA in molecular cell and developmental biology. Ettin is a scuba diver, water skier, wilderness first responder, and a hobby aquarist. She is a lab technician in the Gutman Lab for ink RNA biology at Caltech, where she performs experiments to help better understand RNA protein interactions in several models, including the SARS-CoV-2 virus. And after her is Alex Coultrup. Alex Coultrup holds an MS Spaceflight Human Factors with a focus on microgravity operations and is a graduate of the International Space University's Commercial Space Program. She is a student pilot, first responder, always in training, and former US rowing national team athlete. Coultrup works at NanoRacks in the Commercial Space Stations Organization and has a background in space policy and human psychology in space. Up next is Shayna Hume. Shayna Hume is a PhD student in aerospace engineering at CU Boulder, researching Martian entry, descent, and landing algorithms. Hume is a perpetual explorer, a student pilot, scuba diver, and hobbyist. She has previously worked at NASA Goddard, Lockheed Space Martin and Aeronautics, the Aerospace Corporation, and is currently co-oping during her PhD at the Jet Propulsion Laboratory. And last but not least is Julio Hernandez. Julio Hernandez is a PhD candidate in aeronautical and astronautical engineering at Purdue University. At Purdue, Julio is conducting research on multifunctional composite structures with self-sensing properties to develop a structural health monitoring tool that couples vibration and connectivity-based techniques. Julio is also passionate about peer mentoring, botany, space sustainability, and cooking. After completing his PhD in the spring, he hopes to continue to refine his research skills at a national laboratory and make impactful contributions to the space industry.
Hey there.
Hey, how's it going, Dylan?
Hey, doing great, Ron.
Hey, awesome. So I'm just going to bring up my, so we wanted to talk about, I know you guys had some points that you wanted to go over to today. So Dylan, for the first point that we wanted to go over was formation of a team. So take it away, sir.
Yeah, let's talk about it. So I want this to be as interactive as possible. I know it's difficult with the virtual, but everyone's staying up late, or if you're outside of North and South America, maybe it's really early for you, but please be active in the chat. We want to see everyone's responses. Yeah, I'd be curious to know first if anyone in the chat has applied to MDRS, because it's something worth doing, in my opinion. Personally, about 3 years ago, I learned about another friend of mine, a colleague who I went to MDRS, and I was curious because at the time I was starting to look into what to do after studying aerospace engineering at Cal Poly at San Luis Obispo. And at some point, I had the fortune of working alongside Bob Benkin and Doug Hurley at United Launch Alliance. And suddenly the idea of pursuing astronaut as a career actually was something I started to consider. And thus MDRS made a lot of sense. And so you have the option to either apply as an individual or play as part of a team. And it was recommended to me to choose the latter. And so then I sought out to reach out to former colleagues, friends, people I've worked with in the past, or fellow students. And we end up pulling from the Matthew Zockwitz Fellowship Program, which is an incredible program in itself. We also have a member from UCLA, where I'm a graduate student, and we also have a buddy of mine who I met through grad school applications at Purdue. And so together we're a team of 6, and we're very happy to be here and talk about MDRS. And again, please leave your questions in here. We want to hear what you have to say.
Awesome, thank you, Dylan. So up next, actually, we want to talk about the scientific objectives. So I believe Olivia wants to actually take that question away. So if Olivia, if you want to jump on and take it away.
Yeah, definitely. And thank you for the really nice intro, Ron. So I was the crew scientist for our mission. So on top of just living life as astronauts on Mars for our 2-week simulation, we wanted to sort of emulate the types of research that people living on Mars, or the first astronauts on Mars, likely would be doing during their time there. And as Shannon mentioned in her panel, just before we came on, she talked a lot about like the botany garden, the greenhouse, everything like that. So I won't get too much into the nitty gritty, but our goal as a team was to do the sort of research that would hopefully, inspire the next generation of scientists and astronauts. So for example, we had a garden, we had a hydroponics garden. I'll pass it off to Julio in a second and he can talk about his regolith feasibility experiment. But we wanted to do some experiments that we would be able to communicate to others. And through outreach, once we leave MDRS, we wanted to be able to speak to classrooms, astronomy clubs, and things like that to let them know that, being on Mars isn't just for, astronauts, people that want to be, there just to explore space. It's for all types of researchers as well. So Julio, if you wanted to talk a little bit about your experiment, and then maybe you can hand it off to the next person.
Yes, thank you, Olivia. That was a very good summary. For my work, I was the crew botanist for our team, and I had done a feasibility study in which that I was exploring what if we were to take a initial amount of Earth soil to Mars with us and introduce some of the local Martian regolith after you were to process it to remove any of the chemical perchlorates that are in the soil to expand your production. So what Olivia had done was she took it from the angle of a hydroponics, which is a fairly sophisticated method of producing your agricultural produce, but I wanted to do something a little bit more traditional. What I found was that my plants there didn't really like the Martian regolith so much. It's very much a very poor medium to grow anything in. But we also had an additional experiment that Alex had brought in which that she had grown a few pea seeds within a gel suspension.
That's awesome.
Yeah,
Thank you,
so
Julio.
the gel suspension growth, experiment that Julio mentioned was kind of riffing off of his, measurements and his practices for mixing different soil mediums, but we wanted to make sure we were hitting all of our targets and trying to germinate seeds in as many mediums as possible.
Awesome. So I think up next, we wanted to actually talk a bit about the scientific results, because you were there to perform, a lot of experiments and a lot of trials and tribulations and, as an analog astronaut. So I think, this question, I think, will open the floor to all of you. And and just, go from there. So, I mean, you're up now, so you want to take it away, and then we'll kind of just go through all 6 of you and see what your, kind of your part of the mission, and maybe just kind of put a little bit of input and into what actually happened there.
Yeah, definitely. So what we really wanted to do was use our time at MDRS as sort of an education tool. So of our experiments, we've started making some YouTube videos. Hopefully that'll be accessible to anyone with internet access anywhere, so they can kind of see what life is like on Mars. We gave like a little station tour of MDRS, of all the buildings that were there. And we do check-ins halfway through the mission and near the end and at the beginning, just to, so they can see how our minds are changing, as we're living there. I would say most notably for our results, so I'll talk about the astrobiology a little bit, and then I'll pass it off to Shayna, and then Shayna, maybe you can pass it off to Shravan. He can talk about his emergency shelters, things like that. But Shayna and I had an astrobiology experiment where we were collecting soil samples while we were out on our EVAs, our extravehicular activities. We came back, we aggregated our soil samples together. We GPS tracked the coordinates, for where we went out on our EVAs, exactly where we pinpointed where we picked up that soil. And we sent those samples out for analysis, just like we would, if we were sending things back to Earth to get analyzed, or maybe even ideally, doing something like that in-house, but for our purposes, we sent them off. And we were able to, we're showing what sort of species we could find in the soil. Well, I mean, we discovered life on Mars, basically, is what ended up happening, because MDRS is in Utah, which ultimately has soil that has some microbes and bacteria and things like that in it. But had we been real, Martian astronauts, that would have been, completely just like so exciting if we had the results that we had during our mission. But Shayna, I said I would pass it off to you, but I took all the main points. If you'd like to catch anything I missed, go ahead.
Yeah. I mean, I could elaborate for just a moment. So obviously there's life on Earth, so analog missions don't have that level of fidelity, unfortunately. But what was so helpful about these experiments that we did to learn about life on Mars is we could observe where life is most prevalent, what geologic features you're most likely to find the chemical species it is that you're looking for that indicate life. And so you're able to make mission decisions based on this kind of information that you can gather even here on Earth. And in addition to that, we also got to experiment with some different planetary protection protocols, where we experimented with changing our out the airlock procedures to see if our data would be contaminated or not. In a much larger study with a lot more time, that would be a really exciting way to see how humans can interact with the surface of Mars and still preserve the data quality that's coming in. I think we can pass off to Shravan now to describe yours.
Yeah, for sure. Thank you, Shayna. So my experiments were more focused on an operational sense. So 2 main experiments. One of them was with astronaut dexterity. So what we did is we experimented with different types, so different textures, as well as thicknesses and layers of gloves, to quantify specifically how these gloves would affect an astronaut on a Mars mission. Especially as we move into the next generation of spacesuit designs, which is a really active area of research, it's important to understand how to design a spacesuit to best fit the astronaut. So we did this by measuring things such as grip strength, and then also just timing how long it takes to do different types of tasks, as well as standardized dexterity tests across the board, just to see how these would affect our gloves. And as expected, we saw that the thicker your glove, the more your dexterity was impacted. But we learned that by adding an additional snug layer within a larger glove, you could increase dexterity by as much as 10%. And then you could do the same amount by adding a glove with ridges or texture on it. Another experiment we did was for the crew to map and catalog different emergency shelters at our areas of scientific interest. So these different geologic features that Shayna mentioned that we were looking for extremophiles in, each crew then identified shelters that could be used by future astronauts in case of any kind of medical or environmental emergency. We then used a different subset of our crew to assess these shelters independently, both in terms of ease of location, and then just to qualitatively describe what makes a successful shelter. Because at the end of the day, safety comes first, and we want to make sure we can keep our crew safe in the unlikely case that an emergency arises. So Julio, I know you briefly mentioned your experiment. In case you'd like to talk through any more results, I'd be happy to pass the floor to you.
Thank you, Shravan, for the great introduction, or Passover. As I said beforehand, is that I was looking at different soil compositions of earth soil and also Martian regolith, different percentages mixed together to see if we could, use what's already there on Mars with what we're bringing over with tried and true methods of traditional agricultural techniques. What we found is that peas, or at least the peas plants that I had planted there in Germany before I came in and transplanted it into my different soil compositions, is that it grows very well in earth soil. I mean, that's to be expected, but it grows very, very poorly in pure Martian regolith. And even with some small amount of Martian regolith being introduced, it just doesn't retain a lot of water, which is essential to keep the plant healthy. But in essence, I feel like there's still a little bit more work that needs to be done, because we still need to solve the issue of removing the perchlorates that are in Martian soil regolith before we can even get to the point of mixing it in with any of the soil that we bring in from Earth. But I'll pass it over to Alex, because she conducted an experiment in which she used a gel substrate.
Thanks, Julio. Yeah, well, as Ron mentioned in my introduction, I work for a commercial space company called NanoRacks, and we have a sister company that is focused on STEM education. So I was able to honestly take one of these classroom kits that is targeted towards students just learning about space exploration and demo it in the Martian environment, and use a lot of the same soil mixtures that Julio was using in his pure soil experiment and integrate it in with the gel substrate plant germination setting. So we recorded those findings and sent them back to the students, who were very excited to, learn kind of what it might look like to be in a simulated Mars environment, doing the same type of activities that they do in their classroom. And as Olivia mentioned earlier, we did really want to be very education focused. My other area of interest for my research is I'm very interested in the interaction between human behavior and extreme environments. So I actually did some qualitative interviews with each of my crewmates and got to learn about how our personal habits and our daily schedules were impacted by the rigor of living on Mars. And, without giving too much away, we basically found out that we did not keep our predicted schedules quite as well as we thought we might. And what Dr. Rupert said earlier, that you don't get done quite as much as you planned. That was quite a learning experience for us. So hopefully something we can build off of for our next mission.
Awesome. Thank you, guys. That was awesome. And so I think what we wanted to talk about next is actually talking about simulation fidelity. So, I mean, obviously with the isolation, now you actually touched a bit on that right now, I think, Alex, with one of your interests. So, I think if you want to kind of leak, I think you and Shravan are going to take this topic point. So if you want to start it out, so let's talk a little bit about simulation fidelity. So the isolation, limited resources, etc.
Well, I think something that can make or break the level of fidelity of your sim is the hardware that you have to work with. So actually, I'll give to Shravan to start off this topic, as he was our crew engineer.
Yeah, sure. Thank you, Alex. And I will pass it right back to you in a bit. So we were the first crew returning to MDRS since the start of the pandemic. And Dr. Rupert and the rest of the MDRS crew did a phenomenal job of preparing the station for us and for preparing us for the station. That being said, our goal was to live like Martians, to think and to act like Martians every second of every day. And there was a steep learning curve that led to that, and an adoption of a new set of mentalities. And a prime example of that was resource management. So my research area of interest at MIT is in situ resource utilization. So how we use the resources we find on a planet like Mars to support a human crew. That being said, resources are still limited, and a crew always needs to be mindful of that when doing their day-to-day activities aboard the station. So for example, we had to monitor our water usage for everything like washing dishes to things like taking showers and our botany experiments. In addition to that, our network bandwidth was limited, and we needed to send our daily mission reports to mission support in order to keep, one, the public aware of our activities, and two, communicate any issues that arose with the station. And in a less physical sense, our emotional bandwidth. We were separated from our loved ones for 2 weeks. And we were able to send them, updates over email with what we had done every day, but we had to learn how to really lean on each other as a crew. And the last thing I wanted to touch on is that most of the time, crews at MDRS hand over operation of the station to the next crew when they come in. As we were the first crew back in months, we unfortunately didn't have the ability to get it handed over to us, the station. So we had to learn on the fly how to adapt to the situations that arose. Because at the end of the day, the MDRS crew prepared us for the station, but it was still us living in it, and we had to be responsive to that. So a prime example of that is before our extravehicular activities, we had to make sure our spacesuits were fully charged to provide ventilation to our astronauts. So the first night in sim, I spent quite a lot of time getting very familiar with the spacesuits just to ensure that we could keep our astronauts perfectly safe and healthy when braving the Martian desert landscape. And Alex can touch a lot more on the specific operations we took to make sure that our simulation was as high fidelity as possible.
Yeah, thank you for explaining all of that, Shravan. And I think, as we were mentioning, these go very hand in hand. So in my role as the health and safety officer, leading up to the mission and in our pre-mission meetings, which Dylan did an amazing job of organizing to bring us all together, we talked through what we wanted our operational protocols to be, essentially the rules that we would follow while we were in the simulation to make sure we were making it as lifelike as possible, right? Because in these simulations, it really is a lot of what you bring to it that governs the experience that you'll have. So, speaking of the spacesuits, a good example is, we had a very strict checklist before every EVA. I actually performed what, we hope is a pretty comprehensive representation of a medical exam on each crew member before going out on our, Mars walks, essentially. And I did have the power to disqualify anyone who I didn't see as medically fit from going on their Mars walk that day. Thankfully, we all were in healthy condition, but that's something where, like, if you had been disqualified due to some health issue that day, we all agreed ahead of time that, like, we're going to follow that rule in the interest of safety, just like we would on Mars, whether it would be disappointing or not. We also, pulled from a lot of the day-to-day operations that the NASA and international astronauts use up on the International Space Station. So a lot of our day-to-day tasks mirrored, how they might go about one of those tasks. And I feel like it did help us stay in the headspace and, not just be taking a 2-week vacation at a research station, but actually be immersed in the mindset of being on Mars.
Awesome, thank you, Alex. So I wanted to actually, I know Q&A is typically at the end, but I wanted to jump into a question, if you guys don't mind, actually, because it's really relevant to the topic that we're going at. So Eric actually asks, so when you had downtime, did you find you wanted to be alone away from the other crew members, or did you want to spend time socially together? And was it different than how you are in normal life? What are your thoughts on that?
That
Anyone
might
can
be a
jump
very
in.
good one for Dylan, actually.
I can take a stab. I think it's something that I learned a lot about, actually, during the mission, just what everyone's social battery is, and that can be a very wide range, I think it turns out. And personally, I'm someone who really, I think of myself as someone who doesn't have a limit to their social battery. I do fall on the extroverted side of things, but I think that there's still some independence between that and the amount of time that you can spend with others. And personally, I enjoyed being around the crew, and a few of us I can speak for were able to spend time right after we had finished up in the evening and continue to chat about other things, whereas others prefer to do their own thing. And we did have hours off in the evening. We weren't constantly working up until bed every night, though that was a couple of nights. Yeah, essentially, you have you have some flexibility to be alone if you need to.
Thank you, Dylan. So I think, for our final point, we wanted to actually talk about some key takeaways. So I think Shayna, if you want to actually take this, take the floor, and after that, we'll jump into some Q&A if we have some time left.
Yeah, absolutely. I can do that. Thank you again for moderating this. This is lovely. So a quick follow-up that I think leads into some of our lessons learned on what Dylan just said is that it's very hard to separate your work and your social life when you are living in one small tin box in the middle of space or Mars. I think many people learned that over the course of the pandemic during work from home times, that you need to learn how to separate those carefully because it's instrumental to how well you can perform in your day job if you are able to take that time for yourself. So in addition to just all of us having different social batteries, it was fascinating to see how we all handled that in close contact, and was definitely something we improved at over the course of the mission. We had so many takeaways that came from this, both technical ones about what field science is like and personal about what it is like to be a Martian. But at the end of our mission, we distilled it down into 3 major points, which months and months later down the road, I think still represent us perfectly. The first is that we want to emphasize that space is a vacuum without the people in it. This was a wonderful mission. We gained so many skills, we conducted incredible science, and we did learn what it would be like a little bit to live on Mars. But what really makes missions like these incredibly special and memorable is the way that they bring people together and the way that you all learn new points of view, new skills, new perspectives on the world. That can't be understated at all because it is a way that space brings us all together. And we think that is monumentally important. The second point that I wanted to bring up in the takeaway is that the right stuff is changing. The right stuff back in the day was very much a stereotype of what people thought they had to be an astronaut. But today and going forward, as long duration missions become the norm, especially to further and further away locations like Mars, teamwork is the true right stuff going forward. Thirdly, and finally, we want to emphasize that what we learned and that what we hope every other prospective to MDRS learns is that simulation fidelity is key, and that simulation fidelity is also up to you. The staff at MDRS put together an amazing facility, and you can come into it and learn how to live, just like we said, just like a Martian. But that level of simulation fidelity is up to you, and you get what you put into the experience. It's really an indescribable time to go out there for a couple weeks even for a mission, and you can learn more than you've ever expected. But we encourage everyone who begins to apply and to look into it to apply their full selves and the selves of their entire crew to make this mission as realistic as possible, because the benefits that come back from doing so are just immeasurably high. That is the main takeaways that I had to present and that have impacted all of us so very strongly. But I know we have some photos and some slides to share with you today, as well as answer whatever other questions you have, whether it's about Mars or space or what MDRS is like. So I'll hand it back to you, Ron.
Sorry. Okay. So yeah. So thank you very much, Shayna, for that, and thank you all for. So you did share some slides with me. So I'm just going to bring those up here and see if I can actually do a better share job than last time. And let me just go over to here. And I know Julio has a copy of these lying around as well, just in case I have an issue. So let me just go over here and we will find it. It is not showing for me. Hey, Julio, do you have your slides available?
Yes, I do, Ron.
Yeah, do you mind sharing yours out? Because for some reason, it's not coming up on my screen to show, even though it's open.
Of course, of course.
Oh, sorry, Julio, maybe while you pull that up, we could start answering some of those audience questions. I'm not able to see a chat really from my end, but
yeah,
one question that might be fun to answer is Eric asked again, what board or card games did you play the most in your social time? Unfortunately, we only brought one, so that answer is kind of simple if anyone from the crew wants to field it.
I do not remember having any time to play any card games. I'm sorry. I must have like totally, threw that free time right out of my mind. Card games is like the magical question. Who's got the answer to that one?
Are we referring
Cards
to
Against
Cards Against
Humanity?
Humanity?
Yeah, and I think we had a science pack that we brought along especially for it. That was super cute.
Mhm.
Wow, we must have been in work mode because I don't remember that at all.
To be honest, a lot of our free time was also just spent talking and getting to know each other. When we were the only 6 humans on our planet, it was just absolutely fascinating to dive into our humanity, to just talk about, how we were all dealing with the experience, how this applied to our very different lifestyles back on Earth, and to our different backgrounds, and just to learn from each other. Because what I at least learned is that the crew was such a valuable resource to learn from. We come from such diverse backgrounds, and everyone is so impressive and so passionate about what they're doing that it made me want to learn more and become a more well-rounded person. And I think I speak for all of us saying that we learned so much from each other every minute we spent together.
And I think that definitely applies to one of the other questions in the chat of what would we agree is the most surprising lesson learned. Hopefully we weren't too surprised to find that, it's easy to get along with one another and we were a good fit, but just to agree with what Shravan just mentioned, just the human element of this mission was really, really cool.
Awesome. Now we actually may have some questions coming from different streams and platforms. So maybe Jay, James, Altspace as well. Do you have anything coming from the other areas that I can't see?
I'll go ahead and jump in if you want.
Oh, there we go. There's Alts. There we go. Go take it away.
Yeah.
Wow, that's nifty.
Yeah, sure. As you were each introduced, you had such impressive backgrounds and resumes. And with the recent space launches of tourism, there's kind of a shift that we're seeing where, it used to be that the goalpost was always just becoming an astronaut. But it seems like now it's more, there's going to be distinction. There's, becoming an astronaut, but also becoming an astronaut because your skills are going to do something really amazing in space versus, getting to go for the experience. And you've all worked so hard. I wonder if you could talk a little bit about your dreams, your visions in your own future there.
Oh my gosh, how much time do we have? I said, oh my gosh, how much time do we have? Like, that's everybody in this group's favorite question. Sorry, go ahead, Alex.
Oh, I don't think I have a direct answer to the question, but I did have just a thought to share on this. One of the recent suborbital astronauts that went up is a mentor of ours from the Matthew Isakowitz Fellowship Program, of which myself, Shayna, Shravan, and Dylan are fellows, and Sarisha. And, I think it's a little reductive to phrase traditional astronaut missions versus modern ones as simply like work versus the experience, because we're now seeing that in these suborbital missions, there's so much opportunity to perform science and, get a lot of scientific benefits out of the, additional time in microgravity essentially that's available on these missions. So that was not an answer to the question asked, but a comment that I think that we all feel is an important distinction. And I think all of us are grateful to see more and more opportunities opening up for, doing work in the environment of space, no matter how that might manifest. So moving on to whoever else wants to take a stab at this question.
Shayna, go for it.
Yeah, and I also just want to highlight, I'm sure it's been talked about in many panels today, but an MDRS alumni, Cyan Proctor, also went to space this year, who was an incredible, side mentor to us as well, answered some questions about what it was like to be an analog astronaut, even after everything with her SpaceX mission started to ramp up. So that connection was also helpful to us. And I completely agree with you, Alex. We can talk about the different kinds of missions that get conducted in space, but ultimately the more people that go to space and have that experience, the better. So being an astronaut doesn't just have to be a job title. It can also be about the kind of experience that you've had and how that shifted your worldview. I know we spent a lot of late nights at MDRS talking about what that would feel like to all of us. And so it's certainly on all of our minds.
Shravan,
Also,
I
for a
see.
show of hands, how many of us applied to be an astronaut this last cycle? Just to give the audience some thoughts. So we're all there. If they want to give us a chance to go up, I think you'll see some members of Crew 245.
Some of us are not quite old enough yet, but we are
Yeah.
getting there.
I hope they don't kick me out of this conference, but I like Earth.
Inspiration 5, maybe.
I'll be your ground patrol.
I wanted to just piggyback off of something that Shane had said about the fact that, because space is becoming more accessible, it changes people's worldview. And this is something that Frank White, who's a space philosopher, has dubbed the overview effect. Going to space changes your perspective of life here on Earth and helps you understand how to better apply your skills and background to benefit life on Earth. And I think that's a mentality we all share. And a great example of this is just on this week's Blue Origin flight, William Shatner, Captain Kirk himself, went up to space. And he came back with these incredibly sobering revelations about how fragile Earth is and how it is our blue marble, our blue planet, and how space exploration helps us learn more about the universe around us. But at the end of the day, we are all citizens here of Earth. And the more people that can go experience that and understand that, we have to come together as humanity to solve these challenging problems facing us together, I think that it's a great step in the right direction. And we would all be happy to be a part of that frontier to knock down those boundaries and make space truly accessible for everyone.
Mhm.
Awesome. Anybody else want to go with that? I know we're kind of getting over time, I think. Luckily, we're actually the last event of the day. So I think they're probably getting used to me going over on things. So that's probably, they said, hey, we should go last. But no, I think
If I can just say, we wouldn't be here talking to everyone, speak to you, Ron, speak to the audience, getting to interact with each other as crewmates, even to this day, if it wasn't for MDRS being a thing. So we're really appreciative for the Mars Society, for the Mars as a research station, and it's amazing how even this society alone is helping to gain access to space.
awesome. Now, there is one question I think I'll try to sneak in just before we head out, is because I think we didn't talk about this in this chat, is really what you're eating. Because I think, Julio, weren't you actually the crew chef? Or one of the crew chefs? So I wanted to, so what were you guys eating on Mars? I think that's a very interesting question.
I was the unofficial chef. I have a passion for cooking, and I often joke around that if I hadn't gone into engineering, I would have gone into culinary arts, and lo and behold, I'm doing my PhD now. So I'm pretty far into this track, but that doesn't stop me from practicing my skills in the kitchen. Cooking food over at MDRS is a unique challenge because the food that is available to you is very much freeze-dried or has to be rehydrated, and that presents a challenge when it comes to resource management. As Shravan said earlier, is that you have to tightly control how much water that you're using, not only for cooking, but for cleaning and making sure that you have everything else to keep your environment very sanitary. But for cooking, luckily there was a good abundance of flour and corn flour, especially. I come from a Hispanic Mexican background, so I was able to use the corn flour, the masa that was there in the pantry, and had a lot of mileage out of that. And I was able to make empanadas, tortillas, sopes. Even made pizza, as what Dr. Rubert had mentioned, is that pizza seems to be a commonality between all crews, in which if you have the yeast and you have the water and have the flour, you can make the sauce with the freeze-dried or dehydrated tomato powder that's there, as well as the dehydrated cheese, as well as any of the other toppings that you want to throw onto there. But what really surprised me was that I was able to really be very creative with what was available to us. And I think what really helped us was having a large variety of spices so that we can try out different types of dishes. You know, Indian food, we had Mexican food, and we had, you know, classic American food as well. So having a good variety of diet is essential. But I think what was the most important thing for us that really helped our crew obtain success or maintain a high level of energy was our ability to prioritize eating together as a crew, at the very least for breakfast and at the very least for dinner, where we were able to come together and, you know, we could talk shop if you wanted to, but the point was is that we all sat down at the same time and we enjoyed sharing a meal. And it's not just the food, it's the company. And having the crew together makes all the difference in the world.
And I think that, you know, you're going to be hungry after a long day of EVAs either way, but truly Julio's amazing cooking really just leveled it up for us. And, you know, as we were mentioning earlier, the human experience, just as much as the scientific experience, was so important for our mission. I think something that's different about our crew than many analog crews is, you know, we didn't just toss together and we're never going to see each other again. You know, it's our intention to remain connected personally and professionally going forward, perhaps going on further missions in the future as a unit, and carrying on some of the research that we started on this, our very first analog mission. And you know, all of those little elements of planning ahead, really talking with each other and respecting one another, and, you know, something as simple as sharing food and playing Cards Against Humanity. I think it really helps with that bond. And, you know, what Shayna mentioned from our lessons learned is it really is all about the people in addition to the skills that we may have as people.
Awesome, thank you. Actually, every time I talk to you guys, I don't think coworkers, I think family. You know, just the way that you all the energy and synergy you have together. So it's just fantastic. So I think we should probably wrap it up for this session. I know we could probably keep talking for hours and hours and until people all fall asleep at the keyboard. So I'd like to, obviously thank you for coming again. It's been an absolute honor and privilege to moderate this panel and to speak to you all again. So yeah, if you have any closing words or thoughts, the floor is yours. And then I think from there, we will say adieu.
Maybe the last thing we can share, and it was mentioned in the chat as well, anyone in the audience can follow along with the rest of our journey. And this is through the Red Planet People Instagram, Facebook, and Twitter. And this is really just the beginning. So thank you again for letting us speak to you all. And thanks again to the Mars Society and MDRS.
And we love you, Ron.
Thank you. You guys too.
And if I may say one last thing is, if whether you want to be an astronaut or not, this is a very life-changing experience that anyone can apply to and go through yourself to see what it's like to be in this environment. And if you ever have the curiosity or ever had the thought of like, what would it be like to be an astronaut? Do I have what it takes to be an astronaut? Put yourself in that environment and try it out here first, because an analog expedition is all about seeing what works here on Earth before you actually do it in real life out there.
Yeah, everyone, if I can do it, you can do it.
Okay, thank you guys. I think that's it for us. So Jay or James, whoever's in the still left in the hosting side, I think that's it for us.
Thank you, Ron.
Good night.
Thank you so much. Stay safe and stay healthy.
Thank you, Mars Society.
Mhm.
Bye-bye.
Everybody.
Bye, guys.